Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSC in Institute of Aeronautical Engineering, Hyderabad. So in this video, I'm going to discuss about graph coloring algorithms, various definitions and terminologies we're going to see in this video. So the very first thing is that, so what is a subgraph here? So subgraph of the graph is nothing but some part of the graph. So if I'm going to have a graph like this, and this is the graph we are going to have, and subgraph means I can able to take some part of the graph, so I can able to say this should be the subgraph, otherwise, and this should be also subgraph of the graph. So that means the vertex what I'm going to have, so the vertex that I'm going to have is that A, B, C, D. The subgraph also, the vertex that should be A, D, C. Similarly, the edge should also be subpart of that. So that's why the graph, subgraph is the graph. So it should be some part of the given graph. So if you look at this, so this is the graph I'm going to have. So in this one, H1, so D and C. So this is the subpart of the graph, and H2. So this one I draw. So this one also subpart of this graph, and this is another graph. So where I can able to take some part of this graph. So here H1, H2 and H3 should be all the subgraphs of the given graph G. And next one is bipartite graph. So what is this bipartite graph? So a graph is said to be bipartite. So if the real vertices of the given graph is the union of two disjoint independent sets. So that should be partite set of it. And these vertices is going to be partitioned into two sets such that each set should be independent. So first one is matching problem, and next one is job assignment problem. So if I'm going to have a boys and girls, and the vertices are going to be divided into different categories. So the vertices should be the girls one side, and the vertices of one side should be the boys. In between them, mapping is done, so that's why it should be the matching problem. And job assignment problem also there. So here I can able to consider the set of vertices should be as workers and set of jobs. So the mapping is done between the workers and jobs. That's why it should be a bipartite graph. So a graph is said to be bipartite if the vertex of the given graph should be the union of two disjoint independent sets. Then I can able to say that should be the partite set of the graph. So example is boys and girls mapping and workers and jobs. Chromatic number. So the chromatic number is nothing but how many number of colors that are needed for coloring a given graph. So if I'm going to consider a graph like this, so how many colors are needed for mapping this? So if I'm going to be mapped with one color, so let it be red, and so what is the color I can able to do this be? So shall I use the same color? No. Same color is not possible. So I'm going to map with some other color. And here I'm going to have another vertex. So shall I map with same color? No. So the two colors are not coincide, and these two also not coincide. Same color is there, so that's why I'm able to fill with different color. So the chromatic number of this graph should be 3. So because 3 is the minimum number of colors that are probably required. So similarly, so if you look at this graph here, so in this graph also, I'm going to fill with one vertex as blue and there as green. So no two adjacent vertices should be have same color red. So I have one more option like this. So which color I can able to fill? So both colors are filled with red and green. So as soon as I can able to fill with the other color that should be. So the chromatic number should be. So the three colors are needed for holding the graph. That's why it should be called as a chromatic number. A map and coloring. So map is nothing but the partition of the plane into connected regions. And you can able to color the regions of every map should be almost four colors. So that the neighboring colors is going to have different one. So map coloring is almost also like the graph coloring, such that the regions is going to be considered a vertex in this case, and the edge is going to be adjacency can be considered as a wedge. Next one, scheduling and graph coloring. So the two committees cannot able to hold the two meetings at the same time. So if the two committees have some common member here. So committee 1 and committee 2, so both are going to be joined by some common member. So that should be scheduling. So the model is that so one committee is going to be represented as vertex. So this one committee, so where the group of people. So this one should be considered as one committee, and this one should be considered as another committee. So the model is that so one committee is going to be represented by one vertex, and the edge between the two vertices is another one. So if two corresponding committees have the same common number, the two adjacent vertices cannot receive the same color. So one committee being represented by one vertex, and then there should be a common number in between the two vertices. So the two adjacent vertices cannot receive the same color. That should be the graph color. So normally the scheduling of problem is equivalent to the graph coloring problem. And next one is degree. So degree is nothing but the number of edges that are incident on the node. Then I can able to say that should be as degree here. So what is the degree of B here? So there are two edges that are incident. That's why it should be the degree is 2. And then so what should be the degree of C? So the number of vertices that are edges that are connected C is 1. So the degree of C is 1, and F is also 1. And if I'm going to consider D, it should be 0. And if I'm going to consider E, so the number of edges that are connected incident on the vertex E is 2. So that's why the degree is 2. So like this, we're going to find out the degree of the vertices. So suppose if I'm going to have a graph like this. So if I'm going to consider a directed graph, so I'm going to have two degrees, in degree and out degree. So for V1, what is the in degree? So there is no incoming vertices, edges that are going to vertex V1. So that's why it is 0. And there are two vertices, two edges that are leaving from V1. So that's why it should be 8. So the degree of this V1 should be 0 plus 2, that should be 2. So similarly, what should be the degree of V2 here? So V2 in degree is 1, and then out degree is also 1. This 1 plus is 1 plus 1, that should be 2. So like this, I am going to be calculate the in degree of the vertex in the given graph. So directed means you have to be considered in degree plus out degree, whereas in undirected, so the number of edges that are connected to each vertex should be treated as a degree here. So degree in case of directed graph, so just now what I said. So in degree means the number of edges entering a node, and our degree is nothing but the number of edges leaving a node. So in degree is nothing but the overall degree is in degree plus out degree. So what are the simple facts here? So if G is a diagram with m edges, so the summation of in degree and out degree should also be M, and G is the normal graph with M edges, and the degree of V should be 2M, that should be 2. And next one should be path. So path is nothing but a sequence of vertices such that there is an edge from vertex, each vertex to the source. So a path is said to be simple if each vertex is distant, and a circle is a path in which the terminal vertex coincides with the initial vertex. So a path is nothing but a sequence of vertices. Suppose if I'm going to have a graph like this, so this should be given graph. So if I'm going to have a path from vertex V1 to V2, then I can able to say that should be path from each vertex to the successor. Similarly, a path is said to be simple if each vertex is said to be distinct. And circuit is nothing but the path in which the terminal vertex is going to coincide with the initial vertex. So if I'm going to have, so I'm going to start with 1. So I'm from 1 to 2 I reach, and 2 to 4 I reach, and 4 to 1 I reach. So where the source and then destination should be same between them, I can have to say they should be the path or circuit. So if we look at this diagram, so the simple part is that, so 1, 2, 4, and then 5. So this is the simple part, and then circuit is 1, 2, 3, 1, 2, 4, 5, 4, should be the other bit. And next I'm going to see about the cycle here. So cycle is nothing but a path from vertex to itself is nothing but a cycle. So if you look at this, so there is a cycle from 4 to 5 and 5 to 4. So there is going to have a vertex like this. So this should be the cycle between them. So a path from vertex to itself is nothing but a cycle, and then graph is said to be cyclic if it contains a cycle, otherwise it should be a cycle. And next one is what are the other paths we're going to have, that should be geodesic path, so which is also called as the shortest path. And these graphs are not necessarily uniform, but it is quite simple, quite possible to assemble to have more than one equal length between the given pair of vertices. And the diameter of the graph is nothing but the length of the longest geodesic path between any pair of vertices in the graph. That should be the diameter of that. So first Hamiltonian problem. So Hamiltonian path. So Hamiltonian path is the path that visits every vertex exactly once in the matrix. And next one is Euler's path. So an undirected graph which is going to possess an inverse Euclidean path. So if one only if it is going to be connected 1, so then I can able to have either 0 or 2 vertices here. So undirected graph is able to possess the Euclidean path. So there is a point between and an undirected graph able to possess an Euclidean path only if it is going to be connected and its vertices are all even integers. And next we'll see about the finite graph and the null graph. So finite graph is the graph so where the vertex edge should be infinite one, and whereas in null graph, so the graph with vertex and other edges are going to be empty. So finite means which is going to have a finite number of fields, and null means the graph which does not have the vertex at edge should be empty. So complete graph, a simple graph in which the number of vertices should be minus 1. And weighted graph means the weights are going to be assigned in each vertex or each edge and between them, then it should be the weighted graph. A planar graph means if I'm going to draw a graph in plane, then I can able to say this should be the planar graph. And subgraph is almost on some part of the given graph, that's why it should be a subgraph. And these are the various representations of this subgraph. And bipartite graph, so where the vertices set is classified into categories like boys and girls and then workers and jobs. And next one, what are the various presentations of the graph? So here I'm going to have three different presentations. So adjacency matrix, incidence matrix, and adjacency list. So these three are the latest graph presentation techniques. So what is the adjacency list, incidence, and this? So instance means that if there is an edge between the two endpoints at an event, so that's V1 and V2 are adjacent. If the vertices Vi and Vj and Vk are said to be adjacent, and the edges is said to be incident upon if it is going to have vertex Vi, and the degree of the vertex is nothing but the number of edges incident upon, and is going to be let G be the vertex and an edge set, and V should be the number of vertices, and E should be the number of edges, which is going to be written ARG. And so here, if I'm going to have the multiple edges in between them, so I'm going to represent. So how many edges that are connected from A to Y to Z? It should be 0, and similarly, what is the number in case C to D? So adjacency matrix means where we can able to take the number of rows and columns, and here the vertices are going to be considered as rows and columns. And in this one, if I'm going to take number of vertices should be 1. If I'm going to have an edge in between them, if I'm not going to have any vertex, then it should be 0. So next one is adjacency matrix. So what is this adjacency matrix? So it should be a matrix where we can able to represent the zeros and ones, whereas in case of weighted adjacency matrix, so we are going to represent the weights in between them. So I want to do what is the edge I'm going to have, that should be 5. And similarly, what is the edge that is going to have from 2 to 3? So 2 to 3, what is the edge that should be 4? And 5 to 4, it should be 7. And 4 to 3, so 4 to 3, it should be 2. So like this, we can able to present the weighted graph. And next one is incident matrix. So G be the set of vertices and edges, and where G and should be the mod V should be the number of vertices, and mod E should be the number of edges. So incident matrix means that, so if I'm going to have an endpoint of E, then I can able to say that should be 0, otherwise it should be false. So from W to A, there should be an endpoint, that's why it should be 1, and W to B also 1, and from 1 to C, it should be 0, and D to X to Y, it should be D, that should be 0. Next one is adjacency list representation. So here it should be the array of mod V elements, one from each element in V. So for each V U in V, the adjacent points are set to be adjacent to each other. So if I'm going to have a graph like this, so I'm going to have the set of vertices. So 1, 2, 3, 4, and then 5. And what are the vertices that are counted from 1 is that 2 and then 5. So the 2 and 5 is going to be drawn. And similarly for vertex 2, so 3, 4, and then 5 is there. So 3, 4, 5 is the vertices that are going to be connected. And next one is the spanning tree. So spanning tree is nothing but a graph, just a subgraph that contains all the vertices, and it should also be a tree. A graph may have a more number of spanning trees. So if I'm going to have a graph like this, so there is one form of the subtree or spanning tree, and this is the other form of spanning tree, and this should be another form like this. We are going to construct different types of spanning trees here. So the spanning tree of the graph is just a subgraph, but it is going to contain all the vertices, and the graph is going to have many subtrees. So if you look at this, so there are the 4 vertices are here. So that's why 2 power 4, that should be 16. So there should be 16 possible subtrees are going to be drawn from complete graph. So 1, 2, 3, 4, and 0 here also 1, 2, 3, 4, total is 16 possibilities I can able to get. So next one, how we are going to construct a spanning tree from the given graph. So for that we're going to have different types of algorithms like Kruskal's algorithm and then Prim's algorithm. So these two algorithms are going to be used to find the spanning trees here. So how the Kruskal's algorithm is going to be constructed means, so first of all you have to draw the vertices, and then among this what is the new one is going to find out that should be one. So that edge is going to be drawn, and then what is the next new way that should be two, and then what should be the next new way of. So while selecting the next vertex, it does not even form the cycle, so that's why this control is going to be rejected. We're going to construct 5, so loop is going to be, that's why it should be 5. And then 7, so 7 is nothing but vertices. So these are the two types of algorithms that are available for constructing this spanning tree. And while in case of this Prim's algorithm, so initially I'm going to start from vertex. So from here, what is the what value that should be 1? So 1 is going to be drawn. And similarly, what is the next vertex that is connected here is 2. So this is going to be drawn. And similarly, if I'm going to take 4, so 4 is not going to be formed. So as well as is going to be formed, that's why this one is not going to be selected. And 5, so I'm going to draw 5. It is also going to form the cycle, that's why it is not so listed. And then 2 is also going to be uh, 7. Next one is 3, so 3 is going to be selected. Like this, we're going to construct this spanning trees here. So these are the various terms and terminology that is going to be used for construction of graph coloring and then algorithms. So we'll see in detail about the Kruskal's algorithm and Prim's algorithm by considering various examples. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.